So in this video, we are going to talk about solving systems of equations by substitution. And this is my favorite way to solve them. So we are going to do where we write the steps on the left and we're going to do a problem on the right. So my problem is going to be 3x minus y equals 4 and 2x plus y equals 8. So you will get a system of equations. A system of equations is when you have two or more equations and two or more variables. So in this case, I have two variables, x and y, and two equations. So this is my first equation, and this is my second equation. We like to number them just so we can talk about them easier. So the first step number 1, is to rewrite one of the equations. So you have either x equals some stuff or y equals some stuff. Now, it doesn't matter which one, x or y, and it doesn't matter which equation, so make sure that you pick the easiest one. So in this case, I'm looking over here. You don't generally want to pick one that has a coefficient, that's a number out front, because we'd have to divide by that number, and it might give us fractions. So pick one that doesn't have a number out front, and if at all possible, pick one that has a plus out front. So this is going to be the easiest one because it's got a plus y. There's no coefficient. So this one is going to be easiest. So I'm going to pick that one to rewrite. Okay, so to get either x equals by itself or y equals by itself, I want to pick this one because there's no coefficient. So I'm going to get y by itself. So to do that, we subtract the x term. So y equals negative 2x plus 8. So now have I done step 1? Yep, that's finished. So on to step 2. Step 2 is we are going to substitute. That's why it's called substitution. Okay, substitute, sorry, I lost, my spelling got the best of me. Whatever x equals or whatever y equals into the other equation. And it's very important that you put it into the other equation. If you put it back into the same equation, it won't work. So on this one, I always want to, after the x equals or y equals that I've gotten by itself, I want to put what it equals in parentheses, okay? Put what it equals in parentheses. So then what we've got is our first equation says 3x minus y equals 4, correct? So here it is, and a little post-it. 3x minus y equals 4, yeah? And the one we just solved says y equals negative 2x plus 8. So we put that in parentheses, and now when we substitute, we're just going to take the stuff that y equals and slide it, just like a puzzle, into the place for y. Okay, so we're still going to leave the equal sign and the minus sign. We're just going to put that in place of y. So that 3x will stay. The minus sign will stay. The only thing that's getting replaced is the y. And the y is getting replaced by this stuff that it equals, negative 2x plus 8. So that was in place of the y. Bring down your equal sign and the 4. If you're saying to yourself, man, Mrs. Black, this kind of looks familiar, you have done this before, probably in Algebra 1, maybe in geometry. So you might really know how to do this. But stick with us so you can see there are some word problems and some stuff that we're going to get to. So then you're going to solve the equation to get a value for the variable. And a value is a number. So we need to get a number for that variable. So the first thing I see is this negative. Anytime you have a negative or a number in front of parentheses, remember you have to distribute it. So this is going to be 3x minus negative 2x. So and you could put a 1 here if it helps you. Negative 1 times negative 2x is going to be positive 2x. Negative 1 times 8 is going to be negative 8. Okay, so we've got this. Then anytime you see two terms that both have a variable, we need to combine those terms. So we've got 5x minus 8 equals 4. And now we need to get this x by itself, now that my terms have all been combined. So I'm going to add 8. 5x equals 12. And divide by 5. And x equals 12 fifths. Okay, well, we got a fraction. Not super fun, but not terrible. We can still deal with it. Step 4 then, once you have one of your letters equal to a value or a number, then we need to take that and we're going to back substitute that number into one of the original equations. And we do that just because we don't want to compound it if we make a mistake. So one of the original equations, I can either pick equation 1 or equation 2. I'm going to pick equation 2 just because it looks a little bit easier. So I've got 2x plus y equals 8. And I'm going to take this 12 fifths and put it in there for x. So I'm going to have 2 parentheses 12 fifths plus y equals 8. So when you multiply fractions, you multiply, this 2 would be over 1. 2 times 12 is 24 fifths plus y equals 8. And then we would subtract 24 fifths from both sides. Okay, so we would need, in order to do, out here to the side, in order to do 8 minus 24 fifths fractions, we have to get a common denominator. So common denominator here would be 5. So I'll have to multiply top and bottom by 5. So that would give me 40 fifths minus 24 fifths, which gives me 40 minus 24 is 16. So y equals 16 fifths. And to answer this, every single time you answer one of these, you need to write the solution as an ordered pair. Okay, so you always are going to have parentheses with the x value, which in this case was 12 fifths, and the y value, which in this case was 16 fifths. Every single time you have to write it as an ordered pair. Are there any special cases to this? Yes, there are. There are a couple special cases. You can, just like we saw with graphing, we can have no solution. And we can have an infinite number of solutions. Okay, when you have no solution or an infinite number of solutions, what's going to happen on both of these is you will not get an x equals a number or y equals a number. Generally what's going to happen is they will cancel. There'll be like 5x minus 5x. So then that would be no x's left. Okay, so generally they will cancel. And to have no solution, you will get a false equation. Okay, something like -2 equals 8. Does -2 equal 8? No, never. Never has, never will. In order to get an infinite number of solutions, you will get a true equation. Something like 7 equals 7. Does 7 equal 7? Yeah, all the time. So when your x's or your y's cancel, that's generally a sign that you are going to have a no solution or an infinitely many. So you just have to check. If it's false, none. If it's true, infinitely many. I've got 3 pages of stuff to talk about, so don't get excited that we're done. Next one, we're going to solve this by substitution. 2y equals x, and x plus 3y equals 28. Okay, so our first step was to get either x or y by itself. Well, if you look right here, this already has x by itself. X equals some stuff, right? The x is by itself. That's already going on. So do we need to solve for another one? No. We're just going to sub that in to equation 2. And this is equation 1, and this is equation 2. Probably shouldn't have put those at the beginning. It's equation 1, it's equation 2. Okay, so we are going to take this 2y stuff and put it in place of that, in place of this x. So once I do that, sub that in, it's going to say 2y instead of that x. Then I'm going to bring down my 3y and bring down my 28. So see, all I did was replace that x with something that it's equal to. So now, again, we need to combine some like terms. 2y plus 3y is 5y. And solve for y to get a value. 28 and 5 can't be divided by anything. Okay, so we're going to get a fraction again. Sorry about that, but sometimes that's just what happens. Fractions need love too. If you don't like fractions, then fractions have to deal with like slices of pizza, slices of cake, slices of pie, all things that I love to eat, so I love to eat fractions. Y equals 28 fifths. So now what do we need to do? Now that we have a value for y, we need to sub that into our equation 1. So our equation 1 said 2 times y equals x. So 2 times 28 fifths equals x. To multiply this, we put that over 1. So 2 times 28 is 56. 1 times 5 is 5. That's x. Okay, well, that was fun. So now we are not done. We are not done at all because we have to, as always, write our answer as an ordered pair. Remember, x goes first, so I'm going to get my 56 fifths first, and y goes second, 28 fifths. Now, not all of your answers are going to be fractions. Sorry that both of these were, but I believe you can handle it. You can handle the fractions. Okay, let's do a word problem. A shop sells roses for $4 each and daisies for $1.50 each. One day, they sold 36 flowers and took in $104. How many of each type of flower did they sell? Okay, so when you are doing a word problem, always, the first thing you are going to do is assign the variables. Okay, the variables you can find by looking at the question. So in our question, it says how many, and then it says each type of flour, right? So we have how many and each type of flour. So how many is going to be number of, and then we're going to have each type of flower. So let's read back through. What kind of flowers do we have? We have roses and we have daisies. So I'm going to make R for roses. So number of, and each type of flower. This is roses. And then what is happening to that? Did they sell? So roses sold. So when you're assigning variables, number of, amount of, how many, something like that, that can count for a number, a noun, and then a verb or an action. So number of, noun, verb. That's what we need to see for all of your variables. And then secondly, we had daisies. So number of, my noun is daisies, and my verb is still sold because they're still selling it. Secondly, we are going to write our equations. Okay, so it looks like I've got a couple things going on. I've got a couple things happening up here. I've got $4 for roses, right? $4 each for roses. And for daisies, I've got $1.50 each, right? So those are the first numbers I'm seeing, $4 and $1.50. Those are in money. Do I have any other things that are in money? Well, if I look, it looks like I've got 104. So $4, $1.50, and 104. Since those are all money, do you think we are going to have an equation that's going to deal just with money? If you think that, you're correct. So $4 for a rose, that's going to give me 4R. $1.50 for a daisy, 1.5D, and that's going to equal 104. So this first equation was all about the money. All about the money. So all the money numbers went together. Okay, and then if I look up here, it looks like I have one day they sold 36 flowers. 36 flowers. And, well, let's think about this. If they sold 36 flowers and they were selling roses and daisies, well, how many roses did they sell that day? Well, they sold R, because R is the number of roses sold, right? So how many roses did they sell? They sold R. Whatever the number is for R, that's how many roses they sold. And how many daisies did they sell? Just D. And that equals 36. So that's the amount. This is the number of flowers sold. Okay, so sometimes they won't give you a number for in front of these variables. If it's the number of whatever they are, whatever their variable is, then you just put in the variable. Sometimes there's not a coefficient. Okay, and then next we are going to solve by substitution. Now on all the other ones we've got a fraction. We've gotten fractions as our answers, right? But on this one, do you think we're going to be able to get a fraction as our answer? Hopefully you know that we're not, because we can't have a fractional number of flowers. So I need to look for the easiest one to solve. This one is not going to be an easy one to solve for a letter because it's got coefficients. This one looks better. So I can solve for R or D, it doesn't matter. I'm going to solve for R just because it's first. So R equals, and when you have these, you always want your variable to be first and then your number. So I'm going to take that, I'm going to take what that equals, and I'm going to sub it in the other equation. So that was equation 2 that I solved. So I'm going to sub it into equation 1. So equation 1 was 4R. Instead of R, I'm going to put negative D plus 36. So I'm replacing it or subbing it. Plus 1.5D equals 104. And now we're going to keep solving. So distribute negative 4d plus 36 plus 1.5. Oh, that's not 36. Sorry. Negative 4d plus 4 times 36 is 144 plus 1.5d equals 104. Sorry. Now combine my like terms. Even though they're not sitting next to each other, I can still combine them. Negative 4 plus 1.5 is negative 2.5. D plus 144 equals 104. Subtract 144. Negative 2.5d equals negative 40. Divide by negative 2.5. And d equals 16. So that's good. It's a whole number and it's not negative. If I had gotten a negative number, would I know something's wrong? Yeah, because you can't sell a negative amount of flowers. Okay, so now we're going to take that number and we are going to sub it back into one of my originals. This one looks nicer. Again, no coefficients, so nothing to multiply. So I'm going to sub it back into there. So it's going to say, I'm going to have to do that over here. So it's going to, equation 2 said r plus d equals 36. So I don't have r, but I just found out that d was 16. So if I subtract 16 from both sides, I find out that r is 20. Okay. Now, I'm still not done because always in every single one of these, a word problem, even if Math Excel or whatever your homework is doesn't require it, we require your answer in a complete sentence. So when I'm doing this, I want to go back to the question, how many of each type of flower did they sell? So for my answer, I'm going to say the shop sold, because that's what they're doing. They sold, and then D is the number of daisies and R is the number of roses. So R is 20, so they sold 20 roses and 16 daisies. So that would be my answer. All right, one more word problem. And this one's kind of tricky. Okay. A chemist wants to make 6 liters of a 30% sulfuric acid solution. She will mix 20% sulfuric acid with 50% sulfuric acid. Because they're out of 30%. But she needs some for an experiment. She's got 20% and 50%, so she's going to have to mix them together. How many liters of each acid should she use? Okay. So just like I said on the last one, first thing we need to do is define our variables. Define our variables. Okay, so it looks like how many liters of each type of acid should she use? Well, I'm going to do X and Y since they're both acid. So it looks like she has 30% sulfuric acid. No, wait. She wants to make 30%. So 30% she does not have. She has 20% and 50%. So remember, we have to always start with number of or amount of, and then our noun. Well, what is this? It's liters of, and then what percent? This first one I'm going to make 20%, and the second one I'm going to make 50%. Sulfuric acid. Okay, so now what I want you to do is see if you can write the system of equations. Okay, see if you can write the system of equations. The first one we're going to do is volume. So it looks like volume, she wants to make 6 liters. Do we have anything else that says anything about volume? I don't see anything. So 6 liters. Oh, our variables say something about liters. X is the number of liters of this guy, and Y is the number of liters of that guy. Well, if these two things are the number of liters, and I need 6, then if I add those together, I should get my 6 liters. Okay, the next one we're going to do is the concentration of acid, because we need 30%, we have 20% and 50%. Okay, so this is going to kind of be tricky. Ready? So X is the 20%. So I have X, but how much acid is in it? It's not 100% acid, it's only 20% acid. So I need to change the 20% to a decimal and multiply it by X. So it's going to be 0.2. So what do you think the Y is going to be? Hopefully you know that it's going to be 0.5. Okay, now the amount is a little bit where it gets tricky. How many liters are we going to have in total? Well, in total, we're going to have 6 liters, right? Because that's how many liters we need. But it's a 30% acid solution. So it's 6 liters times 30%, because that's the concentration of acid. So all of these decimals are the concentration of acid. So now we're going to solve these. Looks like this first one is going to be the easiest one. My first equation, x plus y equals 6. I'm going to subtract y. So x equals negative y plus 6. And I'm going to sub that, I'm going to sub that in for x. So 0.2 times negative y plus 6 plus 0.5y equals, and I'm going to go ahead and multiply that, 6 times 0.3 is 1.8. We're going to distribute here. So we have negative 0.2y plus 1.2 plus 0.5y equals 1.8. Okay, so when we combine these, I have 0.5 and 0.2, so that's going to be 0.3y plus 1.2 equals 1.8. Subtract 1.2. 0.3y equals 0.6. Oh gosh. And we divide by 0.3, so y equals, oh good gravy, 0.6 divided by 0.3 is, oh, it's 2. Sorry, my brain was not working there for a second. So 2. Now we need to take that and plug it back into one of these ones. I don't want to do the decimal one if I don't have to, so I'm going to sub it back into this one. So I've got x plus y equals 6. I just found out that y was 2. So what is x then? X is 4. So my answer then would be, the chemist should mix, all right, 4 is my X, so 4 is the number of liters of 20% sulfuric acid. So she should mix 4 liters of 20% sulfuric acid with 2 liters of 50% sulfuric acid. All right, that's all she wrote. Good luck on your assignment and let us know if you have any questions.